This is a gauge transformation. Gauge means fence. So here, if we change the values of scalar and vector potentials and found no change in electric and magnetic fields, known as gauge transformation. If we consider the magnetic field, which is equal to del cross A, and if we have a electric field which is equal to del V minus partial A divided by partial T. It should be noted that this is a vector potential. V at this time we can represent this as a scalar potential, and if we have these two, magnetic field and electric field, these are actually can be obtained from in electrodynamics, because if you have electrostatic condition, then electrostatic condition you can have remove this part, and in electrostatic condition the electric field must be equal to minus gradient of scalar potential. But now we are considering electrodynamics, and here B is equal to this and electric uh, field is equal to this. And now if we change the values of scalar potential and vector potential, for example, we have A and we replace this A by A prime, which is equal to A plus delta lambda. So this is the change. We have added some factor like delta lambda, and similarly v can be replaced by v prime, and this is equal to v minus partial lambda divided by partial t. Now we have the two field B prime and E prime. Now due to the transformation, now we have two equation B prime, which is equal to del cross A prime, and similarly E prime, which is equal to minus del V prime minus partial A prime divided by partial T. We are interested to find out the relation where B prime, which is equal to B. If we reach to this condition, then we can say that if we change the value of scalar potential and vector potential, then there is no change occur in the electric field and magnetic field. So this will be the gauge transformation. Now, first of all, I would like to consider this equation and putting the value of A prime. So B prime, which is equal to del cross A prime, which is equal to A plus delta lambda. B prime, which is equal to del cross A plus del cross del lambda, and remember this del cross del, this must be equal to 0, which is a curl of gradient must be equal to 0, and then B prime, which is equal to del cross A, and here del cross A, this is nothing but this is equal to B. So one thing, one magnetic field is satisfied. We change the value of vector potential and there is no change in the magnetic field. Now we are looking for the another one, the electric field, which is equal to minus del v prime. We have the value v minus partial lambda divided by partial t and minus partial divided by partial a partial t, and this is delta lambda. Now after some calculation, minus del v, and this is equal to minus plus del partial lambda divided by partial t and minus partial a divided by partial t, and this is equal to minus lambda partial lambda delta partial lambda divided by partial t. And here one thing, as this must be cancelled out, and then we can say that E prime, which is equal to minus del V minus partial A divided by partial T, and from this relation this is actually equal to E. So E prime, which is equal to E, after incorporating the change in the vector potential and scalar potential, and we get uh, the B prime, which is equal to B, and E prime, which is equal to E. So this is known as gauge transformation.